Good morning, grade 10s. We're moving on to the last lesson in your note package on measurement, which is lesson 4, finding missing dimensions. In this lesson, there's only sort of one new concept that you have, but for the most part, it is just going to be on can you manipulate equations, okay? So what you need, make sure you have your calculators out and make sure that you have your formula sheets out. Okay, um, in these questions, they're often going to give you, it'll just be a word problem and they won't even have a picture of the shape. So you have to be able to figure out what shape they're talking about. So example 1 says the surface area of a soccer ball is approximately 250 square inches. So we know that a soccer ball, or hopefully you know, a soccer ball is a sphere. And because they're saying surface area, so surface area of a soccer ball, you would go to your formula sheet before you do anything else and find that formula. So soccer ball is a sphere. There's our surface area of our sphere right there. So surface area is equal to 4 pi r squared. So let's write that down. Surface area of a sphere is equal to 4 pi r squared. Okay, then what it says is the surface area of the soccer ball is approximately 250 square inches. So you need to know, what do you take out from your formula and what are you going to substitute in 250, right? Are you able to look at this and say, does that go for here? Does it go for radius? What is this 250? And hopefully you realize it would go on the left-hand side, that this question actually calculated the surface area of the sphere for us. So I'm going to put that in. And what is missing? The only thing that is missing is radius. So the only thing I could calculate by manipulating this is the radius. And what we're going to do at the very end is it actually doesn't ask for the radius, it asks for the diameter of the soccer ball. But that's fine, because once you get the radius, if let's say you got the radius was 5 centimeters, what's the diameter of that ball? The diameter would be twice the radius, so it would be 10 centimeters, right? So let's figure out how we would manipulate this and get r by itself. So this is 4 times pi times r squared. So if I said, okay, I want you to get r squared by itself, how would you get rid of that 4 and how would you get rid of that pi? What you would do is, because it's r is being multiplied, the opposite of multiplying is dividing. So if I wanted to get rid of the 4 first, let's say, I'm going to divide this side by 4 and this side by 4. And then what I would have is 250 divided by 4, 62.5 is equal to pi r squared. We need to get rid of that pi, so divide both sides by pi. So that divided by pi would give us this answer. So 19.89 is equal to r squared. How do you get rid of a square? You square root. What you do to one side, you must do to the other side. So the radius of this is that answer square rooted. And my radius is 4.46. Remember that in order to get diameter, you take that number and you multiply it by 2. So the diameter is that radius times 2. And then I could round at the end. And it says to the nearest tenth of a square inch, which means 1 decimal place. My final answer is 8.9 inches. It's not surface area, it's not volume, it's just a dimension, and a dimension would not be squared or cubed. It would just be the diameter of my soccer ball is 8.9 inches. Let's go to this question. A cone has a volume. So that are the only two pieces of information that I need in order to figure out what formula I'm going to use. So I'm going to be looking for volume, and it says a cone. So the volume of a cone is 1/3 pi r squared h. Okay, now let's fill in what they give us. So the volume of a cone, a cone has a volume of. Okay, so they give us the volume. So this is given. 564 is equal to 1/3 pi r squared times height. Okay, determine its height. So what they're going to want us, we're going to be manipulating, and we're going to eventually be manipulating to get that by itself, right? Determine its height to the nearest tenth of a centimeter if the radius of the base is 7. So 7, they said, is the radius. So I'm going to take r out, and I'm going to put 7 in. So 564 is equal to 1/3 times pi. The radius, they said, is 7 squared times height. 564 is equal to, let's figure out what this gives us. 1/3 pi 7 squared. Open bracket, 1 divided by 3. So 1/3 pi 7 squared. Okay, 51.3126. And that is being multiplied by the height. And in order to get height by itself, the opposite of multiplying is dividing. So get rid of that 51 by dividing both sides by 51.3126. And you are left with the height is 564 divided by that previous answer. So 564 divided by this answer, and then I could round at the end, and it says to the nearest tenth. It means it wants one decimal place if it's to the nearest tenth. So your answer would be 11.0. So height is equal to 11.0 centimeters. Okay, one trick regarding pyramids and cones. Okay, so when calculating the surface area of a pyramid or cone, you need the slant height. So when you're dealing with surface area starts with an S, and you need slant height. You basically need a measurement on the object. So I'll show you what I mean. If I was to draw a cone, I have two heights of this cone. I have this inner height here, which we denote as H, and then I have this slant height here, and that's denoted by S. If I was painting this cone, calculating the surface area, and I said, which height would you use to paint this cone? Ask yourself, well, if you're painting the outside of this cone, what does your paintbrush actually touch? It touches the slant height. So for surface area, you need slant height, okay? If we were filling this cone with water, then and we're doing the volume, you need the inner height, which is the vertical height, and that would be this height. So if you're filling the cone with water, I need this height here. If you're painting the cone, the surface area, you need the slant height. And you'll see that in this next example. Okay, calculate the surface area of this cone to the nearest square foot. So first thing, it's a cone, and they want surface area. So let's go to our formula sheet, find surface area of a cone. Here it is. Surface area is pi r squared plus pi rs. So surface area of a cone is equal to pi r squared plus pi rs. Remember that this is the circle, and this is what we call the lateral surface area. which is the wraparound part. And if you're painting this cone, your paintbrush touches the outside of the cone, so we need S, right? If we're doing surface area, you need slant height. This picture doesn't actually give us the slant height. It gives us the vertical height. This is a straight up and down line. This is the vertical height. If I said, well, what would you use the vertical height for? That would be for volume. Vertical height is for volume. We need to figure out the slant height of this cone in order to get this surface area. I hope that you see that this becomes a right angle triangle. So right angle triangle has a 90-degree angle. This is 2. The height is 7. This would be C in Pythagoras' theorem. So C squared equals A squared plus B squared. C squared is equal to 2 squared plus 7 squared. C squared is equal to 4 plus 49. C squared is equal to 4 plus 49 is 53. And in order to get C by itself, it would be the square root of 53. Okay, so the surface area, or sorry, this distance here is the square root of 53. And if I was to go into my calculator, let's figure out what that is. So the square root of 53 is 7.2801. So the slant height is 7 point, let's get that number, 2801. Okay, now that should make sense that the hypotenuse of this triangle is the longest side, right? And that works. So now I've got everything I could calculate the surface area of this cone. So pi r squared is 2 squared plus pi radius is 2 and S is my slant height, and my slant height was 7.2801. So let's calculate the surface area of this cone. So pi 2 squared plus pi rs, so pi 2 and then the slant height. So pi 2 and the slant height, I'm going to use the entire number because I don't want to round until the end. And I get that is my surface area. And I'm going to look at what do they want me to round it to the nearest square foot. So that means no decimals, 58 feet squared. Because remember, surface area is squared. And that would be your answer. Okay, let's look at this last class example. Calculate the volume of this right square pyramid. Okay, so they tell me volume and they tell me the shape. So I'm going to go to my formula sheet and here's my pyramid and its volume. So I need this guy here. Volume is equal to 1/3 area of base times height. Okay, now which H is this? Is this the vertical height or the slant height? This would be the vertical height. If it was slant height, they would use the letter S. Whenever they use the letter H, they're talking about the vertical height. So the vertical height is from the apex to the center of the base, and you'll always get a triangle. So when they talk about H, they are talking about this height here. Okay? So if I said, well, how do we calculate that height? How many of you are able to look at this and tell me what that distance would be? If this entire thing is 4 inches, halfway would be 2 inches. So this triangle, the base of the triangle is 2 inches. The vertical height of this triangle, I don't know. So I don't know what that is. And what would this be? This is my slant height. So it's the height of this triangle, like the face of the triangle. But that would be my hypotenuse, which is 6. Okay, so I'm going to put that in. This is equal to C. And then I'm going to call this side A. And for now, I'm going to call this side B. So C squared equals A squared plus B squared. If I want A by itself or B by itself, um, let me just write that again. C squared equals A squared plus B squared. Okay, we wanted B. The formula for B squared, it's C squared. It's always the hypotenuse minus the other side. So B squared is equal to C squared. 6 squared is 36 minus A squared. 2 squared is 4. B squared is equal to 36 minus 4, which is 32. Square both sides, and my missing side is the square root of 32. If I check on my calculator, well, what is the square root of 32? It's 5.65. So the height is 5.65. Okay. Calculating the volume, it's 1/3, which goes in a bracket. Area of the base would be 4 times 4, because it says it's a square pyramid, times that height, which was 5.65. So let's enter this all in our calculator. So in my calculator, 1/3 in a bracket, so open bracket 1 divided by 3, close bracket. 4 times 4, you could enter that or you could enter 16. And I'm going to times that by this. And the volume of this is going to be, to the nearest cubic inch, 30 inches cubed. So remember, volume is always whatever the units are, and then we cube them. Okay, so for your homework, I want you to find the volume of these 4 objects here. Okay. Oh no, calculate the dimension of the indicated variable. Sorry, these 4 are going to be manipulating and finding. They give you the volume. So you find the formula, put the volume in, and manipulate for radius. This guy you're going to manipulate for radius and then multiply it by 2. This guy you're going to manipulate for height. So do those 4. And on this page, you're going to do all of these questions. So again, you're going to calculate the surface area, but you're missing the slant height, right? So you're going to use Pythagorean's theorem. If this is 14, this is 7, and that's 24, what would C be? So you're calculating C here. For this, again, you're calculating C, right? C squared equals A squared plus B squared. And then here's a couple examples where you could try to draw pictures and put the units on and see if you could get the correct work. And the work is right here, the answers. And then do number 16. Okay, let me look at these last 2. Surface area of a tennis ball. Yep, so this is just, again, manipulating. Surface area of a sphere is this, so manipulating. So do these 2 questions as well, and then that will conclude your homework for this.